Yeah, Ritik, I'm just making you the host and then I'm leaving. Just a moment. Yeah, Ritik. So you're the host now. Okay. All over to you. Ritik, all good to go?
Yeah, all good too.
Okay.
I'll wait few more minutes and
Thank
before
you.
we start.
I'll leave the session in the meantime. Cool.
Sure.
Okay. Thank you. Yeah, Ritik, I'm just making you the host and then I'm leaving. Just
Cool. So, good evening, guys. I think we have less attendance, but still we are good to go. So, uh, today our session is the second session in the DSA and algorithms course. So, before this session, last week we had a session on algorithm analysis. So that was our first session. So a quick show of hand, how many of you were part of that session? You guys can just use the reactions which is in the down bar. Two, I see, three, four, total five people. So is it it? So everyone else is new or what? Total six, seven I could see. Okay, that's seven. I'm still getting some more hands, but cool. So yeah, that looks like quite a good people have that. And actually, so fine. Yes, I see still some people are joining. Cool. So let's start. So today we'll go ahead and go to the next step of the essay, and that is the search algorithms. And if time is still there, we'll continue with some of the basic sorting algorithms. But mostly that perhaps won't happen because since this is the first time we are going into code and the data structures and algorithms part of it, right? Want you guys to, uh, I will want you to throw some problems to you so that you guys can have a industry sort of a experience, not industry experience, more like an interview experience. Why? Because in general, right? So algorithms, when it comes to search and algorithms, the algorithms are pretty simple, right? Straightforward. So that's the crux of it. So if it is that straightforward, no one usually goes and asks you the algorithm directly, right? So what they will do is they will go ahead and give you some tweaked version of these algorithms, or Mostly what you will require this is like in solving some other problems. So more complex problems, the solution, you will use searching and sorting. So uh, cool. So moving up to the session, let me start sharing with my screen. Few ground rules. So at any time you guys have, if you guys have any question, just unmute yourself and ask the question. This session works best when it is interactive. And since you guys have the option to unmute yourself directly, just go ahead, ask a question, and I'll try to answer in my best possible capabilities. Cool. So, fundamentals of searching algorithm. Quick introduction about me. So there are some new folks in the call also. So I just wanted to introduce myself. Of course, there are old people who have done the previous session would remember. So I'm Ritvik, and I am currently working as software engineering manager at LinkedIn. And yeah, it's been around a year for me at LinkedIn. But before LinkedIn, mostly, if you see my experience, it has been Indian startups. Two of my companies here are startup in Mobi and Kuliza. Kuliza was the company where I started my journey with in 2007-8 time, and now after working in different industries, mostly in all the industries. So what I see is in between in Mobi and uh, LinkedIn for around 2 years, I worked for an e-commerce company also, which is Lazada, and that's part of the bigger Alibaba group. Yeah, and that's the biggest e-commerce of Southeast Asia. Cool. So coming to the search and sorting, right? So if I have to stack rank different algorithms and different uh, DSA component, right? So you can think of data structure and algorithm is like more like uh, what you do if you build up a house, right? You first lay the foundation, then you put the first brick, and on top of that you build up a big building, right? So that's how whole of the data structures and algorithm itself works like. So you start up with the base. So base, there are some basic components which you will use everywhere, right? So some of the basic components, if you see, are arrays, linked list, right? So see, these are some of the basic component. Trees would be some other basic component, right? And what you do build up more complex data structures on top of that. For example, stack, queues. So these are the next level of data structures, which uses an array or linked list, right? In fact, tree is also used basic. Why it is basic? Because tree is the component which makes graphs. So the building block of a graph is you can borrow the concept from the trees, right? And when it comes to algorithms, right? So searching and sorting are such basic algorithms. So what would be some other interesting algorithms which you will learn over time would be search, sort. There are different tree algorithms. Then there are a lot of graph algorithms, right? More complex ones of those, right? And searching and sorting will be used in most of your problem solving and building up these algorithms. So it's important to know what is what and where to use which data structure. So that should be the main aim, right? So when it comes to search, right? So it's simple. It's simple to understand, correct? So searching is a process where you are given with some data which could be either sorted or not sorted. It could be random data, and then what you need to look is you need to find some other key and check that, okay, is it present in that given data or not, right? So whenever we talk about searching, so the scope of this search, what we will discuss today, will be related to arrays. So search can happen in a tree also, search can happen in a linked list also, right? But what is the scope of this today's discussion is just related to the arrays. So if you think arrays, right, what is an array? So how do you think array is represented in Java inside the JVM? Anyone has that info? You feel free to unmute and tell me more about that. How is an array represented internally inside Java? When you create a new array, ARR is equal to
It
new
is
array.
represented as a object.
Correct. And how internally, when I say in at what happens more towards it? So yeah, it's an yeah, yeah. Go ahead. Someone else is starting.
Yeah, maybe it's an object. It will have an address to that, and it will have all the elements which are stored in that array.
A collection of same.
Basically, it's a fixed length, right? It allocates memory for all the elements. Say, example, if you define 10K elements, then it allocates 10K memory space for that object.
Okay, so slightly correct, slightly not correct. So when you say object, right? So array ARR, when you create ARR, yeah, ARR int is equal to new ARR of say size 10, right? ARR, is that an object?
Yeah, hello. It's object reference, right?
Correct. It's a reference to the object. It's not an object.
Yeah.
In fact, it's not even a reference to an object. It's a reference to a place in the memory, in the RAM.
Yeah. Yeah, means array actually stores the address for the objects, means address of the objects, right?
Yeah, so it's like a reference where it starts with the first index. So you can access the, yeah. So what it means is that it's a reference to the space which is given, which is allocated in the Java JVM for you. So think of this as a like, when there is a JVM, it starts with some memory. When it is memory is nothing but RAM, right? So when you allocate an array, so somewhere in the RAM it will be stored, right? So where exactly, that address is what array tells you. And so yeah, and inside that you can store objects, you can even store primitives, right? If you create an integer array with small I, it will not store objects, it will store a small int is a primitive object, right? It's not a Java object, but capital I integer integer is an object, right? So array can store anything starting from primitives to objects. So it's like a collection of data, sequential collection. And the most important thing, which some of you mentioned, was that it will be of fixed length. Correct. So now what, when you do a linear search, it's a sequential search, right? So a simple loop where you start with the first element and move ahead with the second element, third element, and keep on comparing the value which you are searching. And if you find the value in any of the places, that means it's a positive test case for you. You have found the number, and that will, from there, you can end the loop. So you can break the loop from there. And if not, what if you didn't find anything and you have reached till the end of element to the end element, that means the number is not there in the array, right? So that's the very basic linear search algorithm, if you think, right? And in terms of advantages of that, is that linear search is simple, very simple to understand. That's how someone does a searching if you have some small amount of data, correct? It doesn't require the data in the array to be sorted. So that's the most other beneficial part of it. Yeah. There is no, it can work on any unsorted data also, right? But in terms of disadvantage, it is very poorly efficient, right? It takes a lot of comparisons. How many comparisons can someone tell me? And what will be the time complexity of a linear search?
Size of the array would be the number of
Yeah, so what it is called in terms of big O? N or linear. So it's of linear complexity.
Complexity.
Correct. So yeah, that's what is the second line. The performance of the algorithm scales linearly with the size of the input. And that's the, if you see, doing a linear search is the worst way of doing a search, right? Because there is no points in guessing. Of course, you can find something if you visit all the elements, right? So this linear search in terms of algorithms is the brute force searching algorithm, right? So yeah, this is the example for a linear search. So if you're searching for a number 86, you start with the first element and notice that the elements in here are not sorted, and you go ahead first, second, third, fourth, fifth, sixth. Yes, you have found it. And then what? You loop out of there, right? So, and say if you are searching for 99, you will go till end. When you reach 37, you see that it is last element, and then still 99 is not there. That means it's a failed linear search, right? So the best case in this case, what will be the best case of searching, right? If you are searching for -23, that would be your best case, right? So best case in this case is big O of 1. The worst case would be, of course, when you are searching for -37 or say some arbitrary value which is not there, then also it will have to look and search for all the elements. So worst case will be n. So average case will be somewhere in between if you find it, right? So it will be big O of n by 2, which is also big O of n. So that's the analysis of the linear search. Cool. So can we do something better in terms of searching? Of course, yes, right? So since we are n is the worst possible way, so let's look about another searching algorithm, right? Which is the binary search, right? So the biggest constraint of a binary search is that binary search only works on a sorted array. So if the array is not sorted, you cannot do binary search on top of it. So what is binary search doing? It's basically dividing it's applying the principles of divide and conquer. So what does that mean? Is that when you have a sorted array, so all the elements are in order, right? So what you do is, like, whenever you have to search an element, what you start doing is you look for the first element, and you take the mid of the element, right? So what would it mean? So if the size of the array is of 10, you take the fifth element, you compare with the fifth element. And there could be 3 cases in there. What are the 3 cases? If you're comparing with the mid element, what are the 3 cases? First case, the number. Yeah, go ahead. Someone unmuted.
The mid value itself is the target value.
Correct. That's the first case. Second case.
The mid value
Less.
may not be the the targeted value, right?
Correct. But
Maybe
what
less
it
than, greater than, or greater than the targeted value.
okay, yeah. So if the mid value is greater than the targeted value, that means what where will the targeted value be now?
Left side of the arrow.
Correct. Left side of the array. That means your first part of first element and till the mid element. Correct.
Yes.
And what's the third case?
Yeah, greater than. Sorry, the mid
Less
value
than.
is less than the target, so it will be right side of the arrow.
Correct. So mid value is greater than the uh, uh, so targeted value is greater than the mid. So it will be on the right side, which means it will be from mid plus one till the end, right? So if you see, that's what is called as divide and conquer. What are you doing? You are just uh, comparing with the mid, and based upon that, you have reduced your problem size to half. Correct. So that's what is a binary search algorithm, right? Correct. So let's take an example of this. So this is an array, and notice that it is a sorted array. Correct. So you are searching for say 18. Correct. So um, uh, in this case, the number with the fifth element is the mid element, right? So what you do, you compare 18 with 5. So since 18 is bigger than 5, what will you do now? You will compare. So what you do is next step is you make your you don't need to make a new array. You just move the low pointer. So this is the low, this is the high, and this is the mid, right? So you move your low pointer to your 18th mm, element, correct? And then what you again find the mid element. So mid element in this case will be 21. So 21, if you see, is bigger than 18, correct? So it will be now towards the left of your array, right? So now what you will do, you will bring high to middle minus 1. So high and low will be at the same place. In fact, it could have come to middle minus 1, or it's in middle now. So it if high and low was at both at this 18th number, so middle also will be 18, and then what you compare 18 with 18 and you find the array, right? So if you see, if you were doing a linear search, how many operations would have required? 1, 2, 3, 4, 5, 6 comparisons, right? But with binary search, you have done this in just 3 comparisons. So the that's the efficiency of a binary search. And so how fast is binary search, right? So first you so first iteration of the loop, you search the region for, so basically if you see, you are keep on dividing into half, right? So whatever it has now, it has to be in logarithmic, and logarithmic of base 2, since you are dividing it into halves, correct? So the time complexity of binary search is big O of log n. So that's the difference, right? So, and we saw in our previous session, right, how much of a difference is there between time complexities of linear and time complexities of log n, right? So when I say time complexity of log n, that means if there are 1024 elements, what's the time how many unit times will a binary search take for 1024? maximum how many comparisons you require if there is an array of size 1024. Can
log
someone,
log to 1024.
so how much will it be? I think it will be 10, correct?
10, yeah.
Yeah.
Yes, it's, the value will be 10.
Right. So now think, right? So worst case time complexity of linear search will be require 1024 comparisons, but for a binary search, only with 10 comparisons you can do this. Right. So that's the beauty of binary search. But the biggest pain is that you need to sort the array, right? And sorting itself is a time consuming thing. So that's one thing to keep in mind. So whenever you are proposing a solution, right, which is say of n square, uh, and you see that, okay, after sorting and doing a binary search, that can be you can achieve it without n square, go for it. Why? Because sorting will take n log n and binary search will take log n. So overall it will become n log n. So uh, that's for any unsorted data. And if there is a sorted data, right, mostly you can use binary search in some form or another for sure. Cool. So do we have any questions till now? Okay, so I think this is easy to understand. Now let's see. Can you guys see this question and just read through it? And if someone of you can volunteer to explain what exactly is the question asking, that will be very good. While you guys are reading, let me quickly run the mid-session polling. Okay, there is no mid-session poll in this. Go ahead. Cool. So have you guys got this thing?
Yeah.
Yeah.
So any one of you can volunteer to explain the class, the details about this problem, what it is asking.
Yeah. So one array is given, and so we need to find the pair having which having a sum equal to x. Means x is, if x is 5, then if the input is given which is from 0 1 2 4 3 6, then output should be 2 3, means 2 plus 3 is equal to 5, and other possible output is 1 plus 4 is 5. So we need to iterate through array, and just need to via iteration we just need to verify whether any two pair having the sum equal to 5.
Correct. So the key is finding two numbers here. Correct. So if you see, it's a very simple variation of a normal search. In normal search, what you do, you search for one element. Correct. And this here you are doing searching for two elements. And the other condition could be that there is no such pair which exists. So in that case, print -1. So what will be the most simple, and if we don't think about optimizing it, what's the most simple way of writing this code for this? Anyone who can?
We can use two for loops.
Uh-huh.
Two nested for loops, and iterate through it, and just in each iteration just add I plus j and is equal to x, and if it is true then just break. And I should start from 0 and j should start from first position of the list.
Okay, I will start from 0, and where will j start from?
From the first.
So that also will start from 0 or
No,
first?
no, from first.
Okay, and when I is equal to 1, what would be the value of j?
Okay, I is equal to 1, j is
So
equal to 2.
it should be 0. Only thing is it should just skip the ith position of the parent array.
Yeah,
The child array should just skip the
Okay, so do you think this code is correct?
I think
No.
j should be I plus 1.
Why?
So it will always be ahead of I.
Why? Why should it
Not
be?
necessarily, right? The number can be anywhere. It can sum up.
Yeah, it is not necessary. Yeah, it is now we are comparing one element with all, right? Means
But the problem with that code is, Ritvik, it will give the duplicate output, right? Meaning, if I already added, say, first position with the 8th position, if I come to 8th position, I should not again try to find the same pair, correct?
Correct. So for what x value this code will give a fault? In this array, so if my input array is this, what x value this code will fail?
Maybe not for this input.
Yeah, it will not fail for this input for sure, but what x is equal to what where it will fail?
Okay, for every duplications, like for x equal to 2, it failed. X equal to 4, 8, 9, 6. Like sum of the same element, 1 plus 1, 2 plus 2, 4 plus 4.
Correct. So if you have x is equal to 12, it will give you 6, 6, but there is only one 6. Correct?
Yes. Yeah.
So yeah, what you mentioned. So how can we solve that problem now?
Just skip the I.
Not skip the I, but j should start ahead of the I plus 1.
Oh, then you will miss the previous elements, right?
Will you miss the previous element?
No,
That's the
we
question,
won't.
right?
So that would be checked in the first iteration.
Correct. So
next iteration will start from the second element.
Yeah, so that's exactly. So if you so sorry, I couldn't see your name. So the person who was telling that you will skip the first element, just think of this. When you are comparing 0 to 1, you are telling that, okay, when you're comparing 1, again go back to 0. But 0 and 1 already have been compared. Why you need to compare 0 with 1 with 0 then? Did you get my point? When I is at 0, your j will start from 1. So what are the pairs it will compare? 0, 1, 0, 2, 0, 4, 0, 3, and 0, 6. Correct? Now say when I is at 4. Correct? 0, 4 already has been compared. You don't need to compare 4 and 0 again, right? So very conveniently, you can start I from j from I plus 1. Correct? But still this code is not complete. What's the part which we are missing?
The return of -1.
Correct. So whenever you are giving an interview, if you solve and give this problem, fine. People will be happy, but they will not be happy that much because you have missed the edge condition in the excitement of completing the code, right? So that's the second part of it. How can we do that?
If found
outside the loop, outside the loop,
what will I do? Which loop? There are 2 loops here.
Outside all the loops.
Outside all the loops.
What will I print?
If not found, then.
Oh, sorry, I have already given this hint here. It shouldn't have been there. Okay, cool. Yeah, so in this case, yes. Yeah, I intended to keep this code like this. Yeah, so yeah, you can start. I deleted from both the places. Yeah. So you start with a Boolean If found, true. If not found, you print no valid pair exists or -1.
Okay.
So what's the time complexity of this code running?
N
N
square.
square.
Correct. Now, can we optimize it? Of course we can. I just told that in the beginning only, right? If there is something which is n square, for sure you can bring it to what?
N log n.
N log n.
Correct. So that's the biggest hint, right? How can you use that?
Can you first use the any sorting algo, then use
Uh-huh.
binary search to find the pair?
No, that's not complete. So it's okay, but not complete solution. When you say binary search to find the pair, how?
So maybe from the first, so for example, in our example, x equal to 5, right?
Uh-huh.
We will subtract first element from x equal to, can you go to that slide where we have defined the array?
Yeah, sure.
Here, maybe we can, 5 is there, right? We can we'll first sort it. Then we'll do 5 minus 0, first element. So then we'll get 5, right? That subtraction. Then we have to search whether 5 is there in the array using binary search. So like that,
Okay, so
it
you
is
need
not there.
one loop will be there, one loop will be there outside, and then inside you will use a binary search, correct?
Yes.
Yeah, in that
So
case,
it
it
won't be
is,
just a binary search, right?
yeah.
So in that case, what is the time complexity?
For loop, it is n. Binary search is log n plus sorting algorithm time complexity.
Which is again n log n, correct?
Which is again n.
So overall, how much is the time complexity?
N log n.
Log.
Log n.
Yeah, n log n, right? Which is better than n square, right? So yeah, this is the optimized code. You can use any sorting algorithm. I'm not going into that, but the best sorting algorithms, which are quick sort, merge sort, heap sort, they do sorting in n log n. So this will take n log n, right? Similarly, now you have this Boolean found. You just need one for loop. So you start with one for loop. So you go to each element, and then what? You find the difference element, which you have to search. And then you search using binary search. So arrays class, util has an array class, which directly gives you binary search. So that's what I am I'm not implemented it again. So this is how you optimize this code. There are advanced versions of using the same problem, solving this problem in N also, actually, which we will revisit in our future classes. Cool. So I think from a code perspective, binary search, this is the code, right? So given a binary search, correct? So that's what, if you see, this is a recursive method, correct? So we need to have an exit condition. What is the exit condition? Is that your left should be always be less than right, correct? If it is even equal to, that means after dividing both of, so left and right is the same pointer which I mentioned first and last, right? So that's how you do. And interesting. Can someone tell me why is this mid calculated in this way?
To prevent the overflow.
Yeah. Can you explain that in more layman's terms?
Actually, if we will do first plus last, and if the array size, if it exceeds the maximum capacity of the integer, then it will be again minus. It will start from I think -1.
Correct. So yeah, you might even get an issue also. So this is the part in the comment is the simple code, which is finding mid, left plus right divided by 2, right? But if you see, right, if left is say almost and it's a big number, and right also if it is a big number, right? they can combine together. If you sum them up, right, that can exceed the size of integer limit itself, right? So writing it this way solves that issue, correct? So yeah, so that's how we find the mid, correct? Now, if mid is equal to number, the number is found, right? And then you return back. This is also an exit condition. Else, what you do, you do comparison and do the search, and do search on what? If you have to do search on either mid minus 1 till number, or mid plus 1 till right. So the same concept which we shown over there. So this is your binary search, simple code, right? Very easy to understand. Linear search, of course, it's even more simpler. I'm not even going into that code. Right, so this is our pair in array. So yeah, it's the same code which is there in the slide. So let's just skip this one. So in general, how much is the difference between a binary search and a linear search, that you guys can see here. So I think I ran this code previously also, right, in last session, right? So when I'm generating a random integer of 1 billion. So of course the time, if you have 10, 20 size arrays, you won't feel the difference. And what I'm doing, once I'm doing linear search, once I'm doing the binary search, right? So it's a random function. So let me just run it while we go to the slide. So this will keep on running. This will take some time, and then you guys will see. You guys can see what's the difference between it, right? The running times. Cool. So second question.
Sorry, Rutvik, one question. To find that mid
Yeah.
element, right? We could do right minus left divided by 2, no?
Right minus left divided by 2. Will it be always be the case? If
So it's all indices, right? Left, right positions,
correct, correct.
Then why it is not a case always?
It could be. It's fine. I'm asking it. I have not. It's the same. It could be the case. I've not thought on this, but yeah.
No, it will never be the correct case. For example, the length of the array is 11, and the left pointer is at the fourth element, which is equal to 3, and the right pointer is on the last element. I would say that is 11. Okay, so 11 minus 3 divided by 2 would be 4, whereas the expected number is 5.
Okay, wait. So when you said array has 11 elements, if right is 11, left can be 4, no? If starting point is 4. Why are we saying? Okay, let's say okay, array has 11 element, and we starting point is 4th number.
Achha,
which
no,
is
okay. So try to understand this, right? So okay, so if the number you are starting, right? So you are keeping on changing it. They are not always at the same position, correct? Now think of this. If they are just forget about what. Take a simple example. If the array is of 10, and if left comes to 9, and if right is as 10, correct? What should be the mid? What should it be? Or even if it is at 10, 10, correct? It can be also Poisson. If you do left minus right divided by 2, it will become 0, right? It should, the answer should be 10 in that case, right?
Right. Yeah. Yeah. Right. Okay. I was actually trying to understand this equation, so thought of that. Couldn't get this equation actually.
Okay, okay. Yeah, that's yes, at least that's a good thinking. But yeah, left plus right divided by 2 will always be true, but it can create issues some places. Cool. So now see this question, the second question. Very simple, right? So to understand, what's the brute force way of doing this?
Linear search.
Correct. You start from the first element till you encounter one for the first time. That will be your output. How can you optimize it?
By starting from.
Can you do?
We can do binary search.
Go ahead.
We can do binary search.
And search what?
We will search one, but we won't stop until I minus one, mid minus one is not 0.
Yeah, we will not stop, and we'll stop only when mid minus. No, so that's not true. Can you?
Actually, we will only consider that index if if 0 is occurred before that index.
Yeah, how would you translate that into code?
Actually, it will be always be. We will just check if the current position minus 1. Current index minus.
So first thing first, of course, when you're talking about binary, so when you're talking about binary, you need to find mid, correct?
Yeah.
So what should be the mid element? For a positive case, what should be the mid element?
It's 9, so it will be 4.
Sorry, what is the element at mid position for
one
exit condition? Correct. And then what? Is it sufficient?
No, it's not sufficient. Then we will check whether this the current position. So let's say the current position is mid. So the key will be it will binary search will return true if it's 1. Then we will again check if the current index minus 1 is 0 or not. If it's 0, then we will say that this is the index. It's the first occurrence of 1. If it's not, then we will reduce the mid.
Correct. So, okay.
And then, so if it's 0, then we will increase the mid. So that's how we will find it.
Okay. And there is one edge condition which is missing. So you are almost given the full solution. There is one edge condition which you are missing.
Actually, if it's not present. No, but actually it's always 0 and 1. So it will always be present.
Correct.
If it is the first element.
Yeah. So for if it is all zeros, your output will be correct because you will never get 1, right? So somehow it will exit. But if all of the elements are 1, this will not be true, right? Because you are looking for an element. If all the elements are 1, the first element will be 1, right?
Yeah.
And then there is nothing before that, correct?
Yes.
So those are the two edge conditions. So did everyone get this thing, right? So let me explain for the benefit of yeah. So these are some of the edge conditions in here, right? So linear solution as simple as this, right? You traverse
the array of zeros and 1. So it will always have.
Who said?
It's Gopal.
So it will either have it will always have either 0 or 1, but within them it can be all
Actually,
1 also, right?
it was written given the array of consisting 0 and 1.
Okay. Cool. So this is the optimized solution. The linear solution, I think everyone gets that, right? So traverse, and whenever you get the first element, you return the I. I is the position of it, right? So optimized solution is this. So again, so you find out the mid. So I am just taking out the lazy approach to find mid here. And what is your, you need to run your loop till your low is less than equal to high, correct? So till that condition you run your loop, right? So what you check is if array mid is equal to 1, correct? Then what you need to do is check that, okay, is my array mid minus 1 is equal to 0, correct? That's true. Then only you return mid. Or if my array mid is 1 and my mid itself is the 0th index, which is the first index, right? So these two conditions have been combined together, right, with the OR statement. So this will give you an exit and the output from here. Else, if your array mid was 1, correct, that means this will be towards the left side, right? So what you do, you make your high equal to mid minus 1. Otherwise, if it was not 1, that means it was 0. That means the first one lies towards the right side of the mid. So what you do, you change your low to mid plus 1. Any questions on it? Did everyone get this thing?
Yeah, I understood what you are saying. But I have a question. This optimized solution, what is the time complexity of this one?
It will be again the log n, right? Because you are again dividing it into half, half, half.
Okay, that's not, yeah, that is log n only, not n log n. Okay.
Yeah, log n. So it's binary search sort of, right? So log n.
Okay.
And n log n, how it can be optimized given that the brute force is n. So linear approach gives you n. So optimize will be always better than that, right? So it's log n. Did I say n log n? If that, okay, sorry.
Yeah, I understood it as n log n, so that's why I asked. So, sorry.
Cool. So yeah, and this is the code. I think yeah, even if there is a code, it will. Okay, so yeah, finally this thing has run. So see, time taken to sort is 124 seconds. This is in milliseconds, which is around 2 minutes. And binary search found it in just 2 milliseconds, and linear search took 200 milliseconds. So see, the almost 100 times better it is linear search and binary search for a big number. Cool. So this is all I have for searching. And if you guys have any questions, please tell me. Otherwise, I'll move to sorting also. We'll try to cover some basic sorting algorithms. Of course, we cannot cover all of them in whatever half an hour is left. So quickly. So no more questions on searching, right? Cool. So sorting, very interesting concept, but the problem is that there are so many sorting algorithms, which always confuses me. Telling you, I have been with so much of experience also, and with more experience, even it becomes more confusing because you lose touch of it. So, what's the best way to remember what you are doing, right? So, I'm trying to give some hints on that, so which I at least use as a keyword. every one of you would have remembered the periodic chart using some song, right? So that's the way to remember the sorting also. So bubble sort, right? So the first sorting algorithm, bubble sort, right? So what's the property of a bubble? So if you think bubble, right? Wherever the bubble will be there in any liquid, it will come towards the top, right? And wherever it is, right? So what you do in bubble sort also is in each iteration, you bubble the largest value to the end, and you do the you compare it with all other elements, right? So in the first iteration of bubble sort, what you will see, the maximum element will go and sit towards the end of the array. In the second iteration, it will go and sit towards the second last position, right? So until what you will do, you will have n iterations, right? So in n iterations, all of your n elements will sit in correct position. So the but don't get it confused when I say n iterations, the time complexity is big O of n. The time complexity is big O of n square. Why? Because to do in each iterations, for to do the comparison, right, you will have to use another loop. So you will have to compare with all other non-sorted elements. So you can think like, right, the array is getting divided into two parts. One is the sorted part, one is the non-sorted part, right? So that's the bubble sort. So remember with the name bubble. So basic sorting, everyone knows, right? So you take an array and then which is in no order, and what you do is you make it into a definite order, which is also any very interesting topic to discuss. Might be since uh, we have some time, I will throw up this question. So how do you think? So in this case, it is an array which is having an integer, correct? So it can be sorted by its value. But think of any complex uh, object like student class, which has roll number, name, all of these things. How would you sort something by that? And in general, whenever we talk about sorting, we talk on the natural order. What's the meaning of that? Do someone have that information? Anyone? Can you guys tell me? So you remember that sort array dot sort, the method I used in here, right? So in my code, if you see in my code, if you see, I'm using this arrays dot sort. And what is arrays dot sort? It takes any iterable. It can be a integer array or it could be any other array. How will it decide in how to sort?
Always in increasing order.
Of what? How would you know the increasing order of a user class?
So we will use a key that is integer at least. So we'll use roll number.
So no, that's not true. So do you guys know about equals, hash code method, all of these methods inside uh, any class?
Yeah. Yes.
Yeah.
Yes. Yes. Yes.
Correct. Similarly, there is a one more method which is the brother of equals hash code. There is a third method. Do you remember the name of it? There is a method called as compare to. So what it will do, it will do comparison between objects of the same type. So when I say student class, which can have 100 attributes to it, right? How should I sort? That will be Java leaves that to us. So what you need to do, you need to implement the compare to method of that student class, and whatever compare to gives you that will be used for sorting. So that's what is. And when you say natural order, so string also will have a compare to. Similarly, integer always has a compare to, right? So we can see that inside Java if you see.
Does the primitive also have this? How that primitive arrays?
Primitive will have that value based on just the value. So you'll see this, right? Compared to, no, this is equals only. So yeah, this is a compared to object for the capital integer class, right? What it is doing, it is comparing, and this is the method compared to. Read more about this. That's an interesting thing, and it's similar to the equals and hash code. So you have read about this. That will give you more details of it. Cool. So going back, so yeah, this is our sorting.
Actually, in compare method, we are just selecting a key by which we are going to sort it. Like if we are going to sort a student class, then we will use the roll number, or we can just specify that we have to sort by the order of marks.
Correct. You can give that field which you want to use.
So isn't my approach correct, or is it something else?
Yeah, it's there. So inside compared to what you will tell that since student compares roll number, okay, or marks, you can, so now what roll number, you can sort by roll number, you can sort by marks, you can sort by whatever you want, correct?
Yes.
So inside compare to, you will put that logic in based on what parameter you want to sort. You want to compare, and you can use multiple of them also, right? If marks is same, sort alphabetically, these logics also you can put.
Okay.
Cool. So yeah, bubble sort. Coming back to bubble sort. Sorry for digressing. So that was, I think, off topic, but yeah, it's advanced Java concept. So bubble sort traverses a collection and bubbles the largest value. That's what exactly you are doing. So if this is your given array, how will this work? Let's go and see, right? So what I do is that first comparison is comparison between 77 and 42. And then what? You exchange them. 42, since 77 is bigger, 77 and 42 is swapped. The next comparison is the number 77 and 35, and you swap them again because 35 is smaller. Next, 77, 12, it goes again ahead. Then finally, 77 and 101. In this case, since 77 is smaller, no swap is required. But you have the bigger element 101 now, which will be now compared to the next element, which is 5. And finally, that will be swiped. And this after first iteration, 101, which was biggest among your array, finds its position in the sorted array. So now, if you think your array is divided into two parts, one is the blue part, one is the black part. Blue part is the part which is the sorted part, black part is the part which is unsorted. So now rest of your comparisons will only be done in the black part. So that's how you keep on going. So if it again, what you will do is you will again start with 42, 42, 35, and then finally 77 will go towards the end. So that's how you write the code. And in terms of algorithm, so simple, right? So you need two loops, correct? And if you have noticed, we were comparing elements which are adjacent to each other, right? So that's what is the if condition. that if A index is greater than A plus 1, then swap and increase the index, right? So this is a typical algorithm. But in general, right, if you think swap is not a inbuilt function inside Java or any other method, right? So how do you do swap? You first store, so if you are doing a swap, you need a temporary third variable. So what you do, you first compare, store the value. So you are swapping, say, A and B. You store the value of A in the temporary variable, copy the value of B to A, and then copy the value of temporary, which is the value existing old value of A. So back to A. So that's the swap which you need to do. Correct. Cool. So if we have n elements, and if each time we bubble one element, we place it in correct, we repeat the bubble up process n minus one time. And yeah, so this is the whole thing in this red part is the part which is sorted. So that's how you go ahead and do it, right? And yeah, so in terms of code, let me see, do I have a code for bubble sort? Right, so this is the code for bubble sort, right? You have two loops. One is the I runs from starting till the end, and then J runs from uh, first element till the number of total numbers minus I. Why is this there? Can someone tell me? Why do you need to run it only till number dot length minus I?
Because
Because that part is sorted already in the first iteration, in the previous iteration.
Correct. So I controls the bigger iterations, and whenever I is equal to 1, that means the last element has already found its place, right? So this gives you the unsorted part. So that's how you run the J. And what you do is you do a comparison and then the swap. So as simple as that. Since this is, you see, you have two for loops blindly, you can tell it's a big O of n square. So that's the uh, part of big O. The average numbers can be lower. Correct. So that's it about bubble sort. You can do some optimizations also in top of it. So what is this talking about is that in case if you run your outer comparison and there were no swaps, what does that mean? At any point,
it's
once,
already sorted.
correct. So the rest of these things is sorted, right? So in that case, you can exit from there. So that's an small sort of, this is what I am sorting. So already sorted collection is there. You can detect it early and then you can stop early. So that's a small flag you can maintain and then do a bit optimized version of bubble sort. So that's what I am doing here. If you see, right, did swap is false. Whenever I do a swap, I make it true, and my exit condition, I add that did swap is there. So if not, no swaps is there, then don't go and run this loop. So this is the bubble sort, right? So a very harsh truth, nobody uses bubble sort. Nobody, because it's so efficient, right? And square. And so no one will ask you to perhaps to implement a bubble sort until it is a college level exam. So no one cares about bubble sort. So so we come to the second sort, which is the selection sort, right? So in fact, no one even will ask you selection sort, and no one will even ask you insertion sort, right? Or you need to focus. So these are just for the sake. That's why if you see, I am skipping over these things quite quickly. So selection sort. All you need to worry about later would be in merge sort and quick sorts, and these are some of the good algorithms to look into. So selection sort. How do you remember it, right? So it's a bit of intelligence brought into the dumb version of which is the bubble sort. And what is the intelligence in there is that rather than comparing with every other element and doing a sort, what you do is you select the maximum element from the unsorted part and swap it with the last element of the unsorted part, right? So that's what you do. Select max element and swap the last element of the unsorted array. So that's a more optimized way of doing. So in this case, right, so what you see a bit up part is the part which is the sorted part, right? So if this is the array, what you do, you first find the maximum of the whole array with the 8 elements, which is 90. And then in the beginning, what was the unsorted array? The whole array was unsorted, right? So what I will do is I will swap 90 and 50. So 90 and 50 are swap, right? And then what you do, you decrement the last index. So that means 90 is already found its place. So now what you need to do, find the biggest element in your unsorted part, which is 80, right? And since 80 is already in its position, you did not do anything about it. You don't do any swapping, right? And when the array ends, when you find that okay, all of your unsorted parts has gone and sorted part has taken over, that means it's the uh, end, right? So you have to, your array is sorted now. Cool. So right, so this also, yeah, so the best case in this case would be if it is sorted already, correct? And the worst case will be if it is sorted in the reverse way. Let me see if there is a selection sort code. Right, this is the selection sort code. So translating it into, so this is the array printing. Okay, yeah. So you start with one for loop, which runs from I is equal to 0 till I is equal to n minus 1, right? And then you find the, okay, this is the another way of done. So we are finding the minimum here and putting it in the first position, just the opposite way, right? So the code is written in a different way. So minimum, you find the minimum, right? Minimum finding is as simple as that. You assign it with I, and then what you do, you start j from I plus 1 till j less than n, right? So, okay, this can also be optimized in here. It shouldn't go, it need, okay, yeah, it is, sorry. Yeah, why do we are starting from I plus 1, and anyway, for min, we will keep it on the first place, right? So we have to go till end. So in this case, the sorted parts will be the minimum first, and it will come towards the beginning of the array, right? So that's why I'm starting from I plus 1 going till j equal to less than n, and then what, you just compare all the arrays. So your min position was initially decided at I, and if you get something which is smaller, you override the min position. Now what, you have got the min position, right? So this min actually is the min position. So that's a good way of writing code. So you should always keep the name of the variables in a way it's more readable. So yeah, min position is j now. So now what we will do, we will just swap it using the same temp variable, right? So this, all of this thing happens inside the outer for loop. So an inner for loop is just for finding the min. Since again we have two for loops in here, so the time complexity is n squared. Cool. So let me quietly take a break here and see if you guys have any questions till now. We have covered quite a good amount. So feel free to throw up some questions.
Regarding sorting, so we'll be covering this the better sorting approach in the next sessions, is it?
Yeah.
Okay. So far we just saw this bubble and selection sort, and both have the time complexity of n square.
And then there is one more called as insertion sort, which is also n square. And then finally what we will do is go to the better algorithms. So do you guys want to continue with insertion sort today also, or should we keep it for the next class? Is it already overloaded? Interestingly, for searching and sorting, we have 3 sessions. That's what I see from the schedule, but that much won't be required. And what I see is that stacks and queues has 2 sessions, but interestingly, there is no session on linked list, which is the basics of stacks and queues. So yeah, I'll try to squeeze some part of linked list in our 3 sessions searching and sorting. Okay, guys. So do you guys have any questions? Throw up anything, right? So industry relevant question.
Actually, I'm a final year student, and I'm preparing for DevOps SRE or SRE types of role. So, what will be the difficulty of these DSA question, or are they going to ask these questions?
So see, some of frankly speaking, I haven't taken a day SRE interview. SREs are usually totally separate org in all the organizations which I see. But in general, if you see what you are talking till now, right, is very basics of it, right? So,
yes.
Right. So from the basics perspective, now think of this, right? If you are, this is a profession, if you are choosing, would rather be it any developer, tester, or whatever, right? So these sort of some things is very common, right? Knowing the time complexity, because even if you're DevOps, you will write some script to do
Yes,
automation.
actually, I am a final year engineering student in computer science, so I'm already familiar with the basics thing. But the like of questions which are given in the bootcamp section, those things require some bit of mathematics things and practice.
And once you are a final year student, why are you telling you want to be a DevOps? Is there something, why you are taking that choice straight away?
Actually, I want to go into system programming and maintaining the packages and all those things. So I'm not at all interested into this normal development.
Okay. So nothing, no offense towards the anything, but in general, right? So a good engineer knows about DevOps.
Yes.
And if you work in startups, mostly there won't be DevOps roles. And but the other way might not be true. Correct.
Yes.
So yeah, so once you think of that, so some of the basics algorithms people might even ask you, right? So like for example, the to find pair array sort of programs, right? That's so basic that that's used for testing that can you even write a basic code or not. So those things will be required, but not up to the level of might be trees or graphs.
Okay.
So that's what my experience tells.
Okay.
Yeah, any more questions? So yeah, if you guys want to, apart from DS, if you guys want some industry relevant questions like what the other guy just asked, right? So I'm here. Related to interviews, how does those interviews happen? What are the things which which people check in interviews? So I can help you guys with those also.
So can you please explain the hiring process for fresher for this system, the DevOps part of thing?
So that will depend on your college. So I'm
Actually, I don't have any college placement. I am going to apply off campus.
Okay, interesting. So so that will then again depend upon the target companies which you are applying now, right? So mostly, usually there would be some screening, telephonic rounds, or you will get a simple hacker rank sort of a test. Depends upon different companies. And in current situation, of course, no one calls you on site, but yeah. So hacker rank test, you get it is that you will do at your from your home, and then what you are called for an on site, and of course then the real interview starts. So all the things which is before you are called on site is just to for the filter out process.
Okay.
And yeah.
So if we apply through upgrade, do we have to go through this filter out process?
I am not the right person. I am not associated with upgrade, right? I am a working professional. I work for LinkedIn. I am just doing this
Just delivering the
freelance.
systems.
Yeah.
Okay.
This is just out of passion and to help the students like you. I am involved in this.
Okay.
Hello, Ritvik.
Yeah.
Can you just explain what is the role of DSA and how much a guy should be have expertise in DSA if he want to be a full stack? Means he should be a moderate or he should be expert to become a full stack.
So first and foremost, right, most of the things which you learn in here, right, you don't use it every day, right? So as I showed you, right, so even Java already has this sort method, correct? You will use sort of that. You will not write your sorting algorithms yourself, right? Similarly, even if you are working with, say, complex objects like of graphs and all, right? There will be some open source library for sure, right? So in terms of work, mostly the interview process is different and the real work is different, right? So interview process. So think of this, right? If you are preparing for an IIT, right? You do preparation, and then the amount of mathematics, physics, all of these things which you read, right? Do you go ahead and use that in your learning? No, right? But that's the process to filter out, given that's the whole pool of people. So the interview process is totally different and the work is totally different.
Okay.
But yeah, what you said, right? So given that nowadays, what I feel is so many. Think of the time when I graduated. The internet at that time was itself. We didn't had internet in one of the good colleges of. I have done my BTech from VIT Vellore. We didn't have internet connection inside our hostels, of course. So there was a lab for us, right? So uh, how would we even practice all of these hacker rank? All of these things were not there, right? So nowadays, what's happening with the amount of knowledge which is there, the people are getting smart and smarter, right? So graduates like you, right? They practice lot of problems, right? So the average level of people who solve DS algo questions are increasing, and thus the even the interview. If you see from the interview perspective, the questions which you ask, that's also even getting more and more tougher.
Okay.
Anything more? Cool. So thank you guys. See you.
Can you please share this slide?
I don't have your email or anything.
Actually,
you
on
can.
the Telegram group.
Huh?
Telegram group.
I am not the part of the Telegram group. Might be you can ask your coordinator and I can forward them.
Yeah, even the last session slide was not shared with it.
So whatever we are doing, I think that video itself is getting recorded. So forget about slide. You can access this video also. I think you can access this video on YouTube also.
No, actually, the small group sessions won't be recorded. Won't be provided the recording.
This thing is going live now on YouTube. I can see that.
Okay, I don't know then.
Yeah,
and
yeah,
it's
it's
getting
on live.
recorded also.
They have some channel on YouTube.
Yeah, yeah. So you will all the slides and not just slides, everything will be there. Cool. And in case the slides are required, you reach out to the coordinator from UpGrad and I can forward them and they can give it. Okay.
Okay. And can you please explain, are the system administrator going into DevOps or the other developers are getting into DevOps?
So system administrator, what do you mean by that? I didn't get it.
The Linux system administrator type of guys, which generally manages the servers.
There is no just one person who will do that, right? So it's a combined role of DevOps when you say, right? So DevOps, for example, in LinkedIn is also called as SRE, Site Reliability Engineer. What does that mean? That means they will not just manage the servers. And when you talk about servers these days, who uses a bare metal? It's all cloud, right? So you don't need a Linux administrator for sure, right?
Yes, but actually they are not going to use just the PaaS product as a service. They're just going to hire the hardware.
No, so even if it is IaaS, right? Infrastructure as a service, if we're talking about, right? In that case, no one will hire just for managing the servers, right? You will also do the deployments. So the DevOps profile also does
Yes.
deployment, monitoring, and build scripts, all
Yes,
the
yes.
things which can do on top of it.
Oh, yeah. So means that is more into the system administrator will go into this DevOps sort of.
Yeah.
Okay.
Cool. Okay.
Okay. Thank you. Thank you very much.
Yep. Thank you. Bye bye. So yeah, have a good night, guys. Bye bye.
Thank you. Bye.
Thank you. Bye bye.
Thank you. Bye bye.
Thank you.
Thank you.